In this video, we will talk about domain and range of multivariable functions. So I want to get into this by looking at an example. So let's let h of x comma y be equal to square root of x minus 2y. So in part A, let's find and sketch the domain. So to find the domain, thinking back to algebra when we first saw domain, the way we do this is we find what I like to call the restrictions on, usually I would say on the input, but in this case we have multiple inputs. So the restrictions on the inputs, plural. Okay. So what are our restrictions? So in a function like this with a square root, the restriction on the inputs is the inside of the root, x minus 2y, needs to be greater than or equal to 0. I need that to be the case. Otherwise, I'll end up with something that's undefined. Okay, so rearranging this, we get x is greater than or equal to 2y. And eventually, I'm going to have to sketch this, so it'll be helpful to isolate the y. If we isolate y, we'll get y is less than or equal to x over 2. Okay, so our domain is all points x comma y such that, so sometimes I'll abbreviate such that as s dot t dot, that just means such that the y value is less than or equal to x over 2. So that's how I would describe my domain in words. Now if I sketch a picture of this, if I draw some axes, so let's get our x-axis and our y-axis. So y, if I have y equals x over 2, y equals x over 2 is a slope, is a line through the origin. The y-intercept is 0, so it goes through the origin, and the slope is a half. That's why I'm drawing it pretty flat. And the fact that I have an equal sign means I do I do make this line solid. And then the fact that y is less than or equal to x over 2 means that my y values could be on that line or underneath. So if I had something like y is less than x over 2, we would have drawn a dashed line. We would have drawn a dashed line for something like this, because y would not be allowed to be equal to x over 2. So I couldn't be on the line. Alrighty, so that is my domain, and now we've sketched a picture of the domain. It's all points in that shaded region. Alright, so now let's find the range. So part B, let's get the range of this. So usually, to get the range, we usually use logic. So if our function is something that we know the graph of, we can use the graph to get the range, or if there's something about the structure of our function that tells us what the possible outputs are, we look for that. So in this case, my function is the square root of some stuff. And the square root of some stuff is always, when I output whatever this is, always greater than or equal to 0. Okay, so now let's think about what the inside, what the stuff could be. Well, x minus 2y can be any real number. For example, I could just let y be 0 and let x be anything. It can be any real number, like if I just set y equal to 0 and have x be anything, I can have x minus 2y be anything I want. So, as a result, the range is going to be the same as the range of just square root of x. Same as the square root of x range. And that range is all non-negative values. So starting at 0, I put a bracket because I do include 0, and I go onwards to infinity. And that's my range. So in other words, there's nothing about x minus 2y being inside my function that limits what the range would be compared to the range of just square root of x, as we're used to from one variable functions. All right, so in terms of our goals, we have talked about how to find the domain and range of multivariable functions. So not every single type of function is just going to be a square root function, like the one that I saw here. But still, the ideas that we talked about, thinking about restrictions for domain, and then using logic and our knowledge of functions for the range, is going to be applicable in general. In the next video, we'll introduce what level surfaces are to visualize functions of 3 variables.